Hello students, welcome back to the next module. Students, in the last module we have completed numericals on differential equation. In this module we'll start with MCQs on differential equation of linear SHM. So let's start with the first question. In the differential equation d square x by dt square plus omega square x is equal to 0 for a simple harmonic motion, the term omega square represents option A, restoring force per unit mass, that is F upon m. Option B, restoring force per unit displacement, that is F upon x. Option C, acceleration per unit mass per unit displacement, that is A upon mx. And option D, restoring force per unit mass per unit displacement, that is F upon mx. So let's see how do we go for it. Now we know that students omega square is k upon m. Now let's make the thing more clear. As we know f is kx, therefore k should be f upon x. Substituting this value of k in the formula of omega square, we get omega square therefore becomes f upon x upon m, which can be written as omega square is equal to f upon m into x, where I have taken x in the denominator. Now if you read the terms properly, on the right hand side of the equation we get omega square is f is force, m is mass and x is displacement. That means it becomes force per unit mass per unit displacement. That is nothing but our option D. And therefore the right answer for this question is option D. Let's move ahead, students. The frequency of a particle performing a linear SHM is phi upon 2 pi hertz. The differential equation of SHM is, and 4 options are given to us. Now how do you go ahead? Now students, first of all recollect the standard differential equation is d square x by dt square plus omega square x is equal to 0. Now if you look at the all 4 options, the first term is d square x by dt square, which matches with the standard form. Next, everywhere you can see some constant value, but thereafter if you check in option C, students, it is not x, it is x square. Therefore one thing is very clear, answer cannot be C. Therefore it's either A, B or D. Now how do you go ahead? So we have given frequency and I have to write the standard differential equation form. So I need to know omega. How do you get omega from n? Yes. So I know omega is 2 pi n. So the MCQ actually starts with finding omega by using the formula 2 pi n. We'll square it and substitute in the standard form. So let's see the solution. So as we know, the given frequency is phi upon 2 pi hertz. Omega therefore becomes 2 pi n, which is 2 pi into, and the value of n is phi upon 2 pi. I cancel 2 pi, therefore students omega becomes phi. Squaring on both sides we get omega square is phi square, which is nothing but, yes, omega square is 25. Moving ahead, now we know the standard differential equation is d square x by dt square plus omega square x is equal to 0. Let's substitute 25 in place of omega square and therefore the answer becomes d square x by dt square plus 25x is equal to 0. That is nothing but option B. Yes, it's option B. Therefore the right answer for this question is option B. Let's move ahead, students. Next question. The differential equation of a particle performing SHM is d square x by dt square plus 64x is equal to 0. The period of oscillation of the particle is. Now how do you solve this problem? As you can see, there is some differential equation given to us. So I immediately recollect, let us compare with the standard form and you can very clearly see I will get omega square from here. To find its time period, how do you get time period? So once we get omega, I know time period is 2 pi by omega. So let's compare with the standard form. Let's get the value of omega and let's then find the value of t. So the solution starts. The given differential equation is d square x by dt square plus 64x is equal to 0. And comparing with the standard form I get, yes, omega square is equal to 64. Taking root on both sides, I get omega as 8 radian per second and I have to find time period. As we know, time period is 2 pi by omega. Let's substitute the value of omega. So we get 2 pi upon 8. We cancel this. This 4 is 8. And d therefore is, students, yes, pi by 4 seconds. Yes, which of the option is pi by 4 seconds? Very clearly we can see that is nothing but option D. Therefore, the right answer for this question is D, pi by 4 seconds. That's all in this module, students. See you in the next module.
Hello.